Hi everyone. So let's start. Let's go to the list of problems from this post 30 days, 30 machine learning challenge. So today is day 8. We have successfully completed a week of solving 30 machine learning related problems. So yes, let's start with day 8. Go back to the chat GPT and say, hey, it is day 8 and here is the problem title. The problem is that we have to detect fake news with a passive aggressive classifier, and yeah, there's a different type of vectorizer. We have used one vectorizer called, I guess, standard scale, kind of doing something similar. So yes, we will explore this today, and also we will explore a passive aggressive classifier to detect the fake news. Okay, so let's start. The task is to detect fake news, yes, using a passive aggressive classifier and TfidF vectorizer. Let's walk through this problem step by step. Like all our previous problems, we are going to go ahead with the similar steps. First, we will load the data. So we will use a data containing news article with labels indicating whether they are fake or real. Then we will pre-process it. By applying this vectorization from TFID vectorizer. Then we will split into training and test data. We will create the instance of model, and then we will train that model with the training data. Then we are going to evaluate the accuracy. We will see how the confusion matrix is coming. We will also see how this classification report will come. Okay, so we can use the fake. Okay, so there is I mean, we can again get the data set from Kaggle. We have been getting data set of for our problems, last three problems from Kaggle only. So we can go to this page and download the data set. Okay, okay. So it says download. I'm going to download it. It is meanwhile it is getting downloaded. Let me go back to. Oh, it is downloaded. So I'll archive it, and then I'll have these two things, fake CSV and true CSV. Okay, so let's see what this is doing. So okay, we will get we will be using this fake CSV news. So let me go back to my challenge, my PyCharm, and move this thing, downloaded dataset from. Where have I put it in my downloaded folder? Called the new directory is news underscore dataset. So it did that unzip there. So it is news data, correct. And we have to move the fake one to our dataset. Okay. So we see it? Yes, we can see it. So let's see. Okay, now what we are doing, we will be pre-processing, we will be applying this. So we today we will be exploring what this is, how this functions, as in what it does, what type of output it produces, and then how the output it produces is useful for the passive aggressive classifier. And we will also explore what this passive aggressive classifier is used for, how does it function, and why is it beneficial for this day's problem. So we will understand all of that. The code is looking something similar to what we have been doing since last 7 days. So uh, let's start. Yeah, let's start, and then when we will reach to the step of pre-processing the data, which is a step 2, we will understand this vectorizer. Okay, so let's start with importing creating a class. um okay, sorry, let's create a Python file, and it is going to be day8.py. Okay, I'm going to add it to my Git repository. And the problem is, let me copy and paste the name of our problem in the file itself. So let's import pandas. First, I'm going to import the pandas as PD. Then import sklearn dot matrix, not matrix dot. Why am I not model selection? We don't have to import from sklearn dot model selection. Import train test split from sklearn dot feature extraction. Import, okay, feature extraction dot text. Import TfidvVectorizer. Then we are going to import the model from sklearn to linear model. Import passive aggressive classifier. Then from, okay, matrix, from sklearn matrix, import accuracy score, confusion matrix, and classification report. From matplotlibrary.py plot, import, not, we will be importing it as plt. Then we will be importing seaborn to generate the heat map of our output, model's output, and we will treat it as with a variable, refer it with a variable called sns. So this is it. Let's start with step number 1. Load the data. Okay, so the data in data frame is going to be, we'll get from the read csv. We'll first set that the name is going to be, what is the name of the file? Fake.csv. And then we will print it. Let's print it. Run this file day 8. Fake news data, fake news. Okay, so we have got the data, but I'm thinking this is the set of all the fake news, right? Wait, this is the set of all the fake news, right? If I want the set of all the news which are fake and not fake, and then get this, yeah, I might have to merge it. Let's train it, and then by the end of the problem we are going to work on it, if this reading this fake csv is going to work or not. So let's read the head a little so that things become more clear to you. Run it, and then see, we are getting title of the fake news, the text of the fake news, the subject, and the date, and these are all fake news. Okay, and then we are going to get uh, f- uh, fake df. Then I'm going to get true news are going to be, let's move the true news also. Move, because all of the newses are fake only, right? Does it have label? It does not have label. So if I see here, we do not have label here. Okay, today we are not getting the. Okay, so it is not getting the. Oh, it is not getting the data set from the Kaggle actually. Uh, okay. See, the same thing will not might not work here as it is. Let me go. Let me see if I can land onto this page. Let me see if I can land onto this page. Okay, the whole database does not exist. Let me try. I've never tried running this, getting the information from here, and run. Let's see if I'm going to get anything from this URL. Print data frame. We commented the line 18 code. So yes, it is 404 as we were getting from the browser. Okay. So uh, let's create the data set, right? So let me go to this discussion. Okay, we have real news, we have fake news. Okay, uh, we have both the. Okay, so what we are going to do, we are going to create our own data. Let's create our own data. So we have got fake news and real news. We are yet to move the true news to our data set. Now the true ones are also here. Let's print the data true ones also and see what it does, it will have. Okay, true. Oh, I ran the wrong command actually. So I have to run this file. So let me do this. Run this file, which is day8.py. Then see what this true thing is going to have. Title, text, subject, and day. Okay. So let's run this. Okay. Let's create the target. Okay. So let's do what I'm getting. So what we are going to do for these ones, the label is going to be 0. It is fake, which means it is 0. If it is true, okay, so if it is true, it is going to be 0. If it is fake, it is going to be 1. Okay, let me see what chat gpt suggests, because I don't want to get confused here. But yeah, that's what I would have done. That merge these two into a single data frame, and then create the label for all the ones coming from here as 0, coming from here as 1, and then train the model on it. But let's say if I'm going to explain the same what ChatGPT has to say. uh, the URL you are using does not exist. Okay, it throws 404. However, from the Kaggle, I get to CSV true true dot CSV, two CSVs, true dot CSV and false dot fake dot CSV. How do you think I should go ahead with it? Also, the structure of the true or false one. CSV is given below. Yes, labeling them appropriately. After that, we'll combine them. Exactly, we'll merge them into one data set where we will label the true ones data set as real. Okay, the fake ones are zero. Okay, true one as one, fake one as zero. Exactly, that's what I was saying. So I've loaded both of them. Okay, true. So it is going to be fake data frame. It is going to be true data frame. Okay, now what we are going to do, label the data set. Step 2, label the data set. We can put it in the pre-process, right? So so true, the fake data frame, inside that we'll create a very the column, and we'll do what. So, okay, so this is how all the all the columns, sorry, rows will be marked as one. It is going to be zero, fake news. Label 0 is for fake news, and then we are going to use true data frame, and then the label is going to be 1, and here label 1 is for true news. Okay, let's print it. Print the fake head, sorry, run it again and see what it will print. Okay, we do see the column added, and the true one is going to be, sorry, true data frame is going to be have label 1. So let's combine it. It is pre-process the data, prepare the data. Okay, yes. So what we are going to do, yeah, we are going to concatenate. So we will use panda dot the concat method to concat this thing. So let's read a little about this. Panda pandas concat method. So I'll go to this official documentation and read a little about it. Allows optional set logic. Okay, concatenate pandas object along a particular axis. Okay, so let's see what it does. So we have to combine true data frame and fake data frame. We have to combine all the rows, right? Okay, we have to combine row wise. We have to all combine the rows, right? And reset the index. Okay, reset the index. So let's do that. Um, data frame. It's data frame. Data frame itself includes data frame, right? Data word. So data frame is going to be panda dot concatenate the true and fake data frame. Axis is going to be row wise, concatenate everything, and then reset index, drop true. Okay, I'll ask, can you please explain this? Okay, so the concatenate is function in pandas is a function in pandas that concatenates, joins two more or more data frames on along a particular x, either row wise or column wise. In our case, we are concatenating true and fake data frames. It is a data frame of the real news, it is data frame of the fake news. Now, zero access zero means we are concatenating along with rows, which means vertically. In this case, we are stacking fake news rows below true. Okay, yes, correct. We are stacking. We are stacking the fake news below true news, which is going to be row wise, right? So that is why we have specified x is equals to 0. Now reset index. After concatenating the two data frames, the index from both true and fake would carry over. For example, if true data frame had an indexes from 0 to 1000, data frame fake data frame had an index of 0 to 1000. The new data frame would have two sets of overlapping 0 to 1000. Correct. Both of them will have the same index. Now what we will reset the index from the fake from the new data frame for the new data frame. It creates a new sequential index from 0 to the total number of rows, ignoring the original indexes from both true and. Why we are doing drop, that is why I asked ChatGPT to explain this argument ensures that the old index is completely okay. It ensures that the old index is completely removed and a new one is assigned. If drop is false, the old index would be added as a separate column if the data in the data frame, which we do not want. Okay, so it would have done if we do not specify it? It would create a separate column, and then there that column would keep the original index intact that we do not want. We do not need it, right? So I'm going to experiment it by keeping it true and false both one by one to see what type of the output it is going to produce. So let's do this. And then we are going to simply, we have created the data frames, we have added the labels 0 and 1, 0 for fake, 1 for true, and then and concatenated it. Now I'm going to print it, data from head, the head. Let's clear it and then run it. So we do see all the ones are first true and then they are fake ones, right. So if I do not do this, the starting ones are one, and ones are fake. Now what I'm going to do, I'm going to do this, and I'm going to see what is the difference. Now I see we have one more column added. We have now 6 columns. Earlier we had 5 columns, right? So the new column is indexes. The new column index has been created, which is keeping the original index, uh, but we do not need it, right? So that's why we will do drop to that. Okay, we do not need this new index, keeping the original index. Okay, so let's run it, and final time we see how the output is. Okay. Okay, thank you, I was drinking water. Okay, so this is the data frame that we have created. Now step 3 is pre-process the data, and it is going to be, first we are going to create. Yes, is so the x which is going to be, which is pre-process the data, which is create feature and target data sets. We are splitting and creating the feature and target data set. The feature is going to be the date from the data frame, the uh, text. This text is going to be the feature, and the target is going to be label. Okay, so it is going to be feature and it is going to be target. Okay, Chalo, that's it. Then step 4 is going to be we use text. Convert the data from numerical feature using okay. So if you remember when we were doing something like, let's go back to our previous problem. This we did, we did a problem on day 5, which was we had to filter spam from a collection of emails. Now emails are in textual form. So if you remember what we did, we applied a sort of what we did, we let's go back and see. On day 4, what we did, we went to our textual um just a second. We had converted some emails. Okay, I did that somewhere else. I'm really sorry, but I remember we did something like that, right? Let me search it here only. We uh, we So what I'm trying to say here is, usually the the this okay, hang on. Spam we have to do day number 5, right? So I'm opening the wrong one, right? Wrong file. So what we did, if you remember, we use a vectorizer called count vectorizer. And what it was doing, it was counting, creating a matrix of the words, of the number of the frequency of words. First it was creating a vocabulary, and then in that vocabulary is the number of unique words in all the emails. And then for each email it was creating how many times that number has appeared. And then it uses that matrix. This matrix is called as count matrix or bag of words matrix. This matrix is then later used for our model, multinomial naive Bayes model, which uses this matrix, to decide whether the email is a spam email or not, on the basis of the frequency of that word, like which yeah uh, on averaging the prediction, which email, if whether the email lies towards the spam one or the non-spam one or the ham one. So what it was doing, emails are in the text form. It was converting the textual data into numerical, because the model understands the numerical input. So we use this count vectorizer. Today we are going to use a different vectorizer called as, let's go back. Let's go back. Yes. We are going to use TFID vectorizer. So what we are doing, step number 4 is, hang on. Step number 4 is uh, convert the data into numeric text. Convert the text into numerical form using what? TFID F vectorizer. Okay. Now let's understand what this and how it functions. Uh, I understood we are using TfidF vectorizer to text convert the text data into numerical form, but I want to know how it functions, how it works, and how it is helpful our for the model passive aggressive classifier. So let's see what ChatGPT has to explain. Okay, I guess it isn't. So let's Great question. Let's break it down into two parts. How does TFIDF vectorizer work and how does it help with passive aggressive classifier? So the TFID vector F vectorizer stands for term frequency inverse document frequency vectorizer. It is a method of converting textual data like news articles, emails, or any text into numerical form, a matrix or number that machine learning algorithm such as passive aggressive classifier can work with. It combines two key ideas: term frequency and inverse document frequency. Now, this term frequency, how often a word term frequency appears in a document, is something similar to the count vectorizer. It is how it sounds. I don't claim that it is because I'm yet to explore what it is, but it sounds like the count vectorizer. That how often a word or a term appears in the window or document term frequency. Now, inverse document frequency (IDF), how important that word is across all documents in the dataset. Okay, then inverse document frequency is that in all the documents of the dataset, how important that word is. So we will understand that how this importance is being calculated. So this term frequency measures how frequently a word occurs in a document. So we will see how total number of terms in a documents, and we will see how many times this particular number has occurred. T appears in the document D. That is going to be the term frequency. For example, in a document, if the word news appears 5 times and 100 word documents, so there is a document of 100 words, and in that 100 words, a news word appears 5 times. So the term frequency is going to be 5 by total number of words, which is going to be 0.05. Now, the inverse document frequency is a measure of how unique or a rare a word is across all the documents in the dataset. Okay, so it measures the uniqueness or rare, how rare it is. The words that appear in many documents, like common words, the, is, and are less informative for classification. So, IDF, inverse document frequency, gives them a lower weight. Okay. The formula for IDF is logarithmic of total number of documents, number of documents containing the term T. Okay. How many? Okay, logarithmic of total number of documents divided by the number of documents containing this term. So it will help us to know how important this word is, as in how unique this word is. If the word news appear in many documents, its idea will be low because it is common. Oh, so it is logarithmic, right? So if the number is going to be very common, so the idea is going to be, so if the number is going to appear many times in many documents, so the idea is going to be less. It is not unique. Conversely, a word like breaking might appear only in a few documents, so the idea will be high. Understood. Finally, the TF IDF score is the product of TF and IDF. How many times that number has occurred, the frequency of that number in the document, multiplied by how unique the number is across all the documents. This score tells us how important a word is for particular document, but also considers how common the word is across all documents. Makes sense. Word like the, is, will have low term frequency, inverse document frequency, even scores, even if they appear frequently because they are common and not meaningful. Words like scandal, fraud might have higher because they are unique, because they are more unique and important to differentiating news from real news. Right, correct. So here it will emphasize more on the uniqueness or unique words. How does TFID vectorizer help? So TFID, TFIDF, oh, it is TFID, not, it is TFIDF, Term frequency, inverse document frequency. TF-IDF vectorizer converts the text data into a numerical matrix where each row represents a document and each column represents a word. Okay. The value in the matrix are the term frequency and the inverse document frequency scores of the words in each document. For example, if your data set has 3 documents and 5 unique words, the matrix would look like. Okay, understood. Now, how does it help with the passive aggressive classifier? Once the data is converted into numerical form using TF-IDF vectorizer, we can feed it to the passive aggressive classifier. What is passive aggressive classifier? Aggressive classifier is a type of linear model. We have worked with linear models before. Where did we work with linear models? Uh, I guess simple regression was a linear one. Yeah, linear model. Yes, linear regression was a linear model. So yes, we have worked with linear model commonly. So this passive aggressive classifier is another type of linear model. It is commonly used for classification tasks, especially in online learning, where the model is updated as it processes new data point. Acha, okay, right. So it updates. It gets updated as it processes each new data. Passive, if the classifier correctly classifies an instance, it does not update itself. Okay, it remains passive. Aggressive, it if the classifier misclassifies an instance, it aggressively updates itself to correct the error. Oh, nice! This sounds a very good model. So what it does, it is a passive aggressive classifier. So if it makes mistake in correctly predicting, it does not update itself. But if it fails in correctly predicting, it updates itself aggressively. And if it correctly classifies itself, it does not. It remains as it is. This makes it suitable for tasks like real-time fake news detection, right? This is why this passive aggressive model we have used, where the model needs to process data and update itself quickly. That is why we are using it. Understood. How does TF-IDF help the classifier? I'm sorry. The TF-IDF vectorizer provides the classifier the meaningful numerical features that represent the importance of the words. It helps in getting the information about the importance of the word in each document. This TF-IDF vectorizer, TF-IDF ensures that the important words like fraud, scandal, or fake are given more weight than the common words like this. Understood? Makes sense. Sparsity handling. TF-IDF scores also result in sparse matrix where many values are zero. Hmm. Understood. Because not all words appear in every document. The passive aggressive works efficiently with sparse data. Efficient text classification. Since passive aggressive classifier is designed for large scale sparse dataset, it works well with the high dimensional TF-IDF matrix, making it ideal for the, so it works with the large database. That's what it is trying to say. I do want to read it one more time, so I'm going to understand it again. The TF-IDF scores also result in sparse matrices where many values are zero. Okay, not big, because not all words appear in every document. Then in that case, this is going to be zero. If it is not going to appear in all the documents, the IDF, how many times number of times the documents appear, total number of documents, the number of documents containing the word, it is going to be one only, and it is going to be very, right, not, it is going to be unique. Not every word number is going to appear it, contain it, so it is going to be zero. Let's the Okay, so I do not understand this. I am going to ask again for explaining this in easy words. So the summary is, what I've understood is this TF IDF vectorizers helps in giving the metrics, which helps in giving the numerical information about the importance of each word, uh, like how important it is, how unique the word is. And then this passive aggressive classifier can use this information to decide if they have to passively update it or sorry, aggressively update it or passively keep it as it is. So yeah, um, I can you help me to understand in easy words, sparse data set in easy words? Okay. A sparse dataset is one in which most of the data is made up of zeros or empty values. In other words, only a small portion of the data actually contains meaningful values, and the rest are mostly zeros. Let's say you have a matrix that represents a customer purchase at a store. Each row is a customer, and each column is a product. We can see apple, bananas, and customer 1, customer 2, customer 3. The value in the matrix tells us how many of a particular product a customer has bought. So the customer one has bought apples three times, banana two, carrot one, and no donuts. Similarly, customer two has purchased apples, no purchase of apples, one banana, one two carrot, and four donuts. And customer two has not purchased anything. So a dense data might look like this. Here, every customer has purchased at least some items, but some customers bought nothing. So the matrix has some zeros. This is not too sparse. Okay. What is the meaning of sparse? Thinly dispersed or scattered. Okay. Very thinly scattered. Understood. Opposite of scattering. Right. So, however, in real world scenarios, especially the with large data set, it is common for most of the entries in the matrix to be zeros and make sense. For example, if you had 100 products and most customers only bought one or two, thus matrix would look something like this, going to have a lot of zeros. This matrix is sparse because most of the values are zeros. Only a only a small number of entries contain actual purchase information. Okay, so sparse data sets take up less memory because we can just store the non-zero values, ignoring the zeros. Okay. Algorithms like passive aggressive classifier and SVM are built to efficiently handle sparse data without wasting time. Okay, makes sense. Now I understand. So why this passive aggressive is making good use of this sparse matrix, which is coming from the TFIDF vectorizers, is because it can focus more on the data which is non-zero and ignore the zero ones. So yeah, that's what I understand right now, but this is something I really want to understand or study more about it later in the future. So yeah, after completing maybe this challenge, I'll come and study more about these algorithms one by one. So stay tuned. Yeah, just a key takeaway. Sparse dataset has a lot of zeros. Makes sense. They are common in text processing and recommender systems. Algorithms like passive aggressive classifiers are designed to efficiently handle this item. Makes sense, makes sense. So we have understood that this TF, which is term frequency and inverse document, let me go back to this. Inverse document frequency gives us the information about how important a word is. Then it can be zero most of the time if the word is like is not occurring, is not unique, or is not that important. Then we use this for our passive aggressive classifier because it will help us in detecting the important words like fraud scandals quickly because of the sparse nature of the data. So that is why we are using these two combinations. So let's go back to our yes, step number 6, and it should be step number 5 for us. Let me close the D4 code. So yeah, step number 4 is convert the data into numerical using the TF IDF vectorizer. I'm just going to add helps in TF. What it does, depict the importance of the word and importance and uniqueness of the word in the documents or data set. Okay, so what we are doing, we are going to do tf idf vectorizer, and we are going to use tf idf vectorizers. Does it need any parameter? Let me go and check. Yes, so I have to tell him that don't include the stop words. um, so I'm going to stop words are going to be for this going to be English, and maximum df is going to be 0.7. Let's understand what this is. Here, what is max df is used for? Okay, so it filters out the common words that appear in the large number of documents. So, why common words for me? What I can think is why common words are not important, are not holding that much importance, is because they will not help us identify whether the news is fake or not. Right? Only the unique words are going to help us identify whether the news is fake or not. For example, 5 times a word has occurred in a fake news, and 5 times a word has occurred in the non-fake news, true news. So this word is actually not of any help for us to decide whether the incoming news is a fake news or true news, right? So we majorly rely on the unique words. So what this parameter is doing is used to filter out the common words that appear in a large number of documents. Especially, it allows you to exclude terms that appear in more than a specified proportion of the documents, which can help to reduce the noise. Perfect. So, the word that I was trying to explain is noise and improve the performance of a model. The max DF 0.7 means that if a word appears in 70% or more of the documents, it will be ignored. Cut. Okay. If the word appears in 70% or more of the documents, ignore. I'll write it, ignore. So we're doing that with this maxed df data frame. Max df, I'll go with df. I don't know what this df stands for here. Yeah, so we have created this tf idf vectorizers, the instance of it, and then we are going to use it to fit transform our x, right? So let's go back to our code, and yes, so we have got the x with fit x with a term frequency, inverse document frequency. uh, we have received it. Now what we are going to do, we are going to use this. Let's print it and see what it shows. uh, Clear it and then run it again. Okay, see, we now see the numerical form, the importance of the words in this data new data frame. Yes. So let's now go to the step number 5, which is split the data. Again, we will split into 80-20 ratio, which is training will be 80%, and the uh, validation data is going to be the 20%. Okay, so let's do that. First we are going to do x train, and then x validation data, y train data, and then y validation data, and then we are going to use train test split. We will specify x will be used to create x train x validate, y will be used for y train y validate. Then we are going to say that the test size is going to be 0.2. This is how we are specifying this 80-20 ratio, and the random state is going to be 42. This will help us to, whenever we are running this program, it will make sure that the same proportion of the split is happening again, the same randomness is happening again. Once done, we are going for the step number 6, which is create and train the model. So the model is going to be passive aggressive one. Here what do I need? The maximum iteration is going to be 50. So let's understand what this maximum iteration is used for. Here, what is this maximum iter is used for? Okay, let's go back. The maximum iter again. So I was right. Maximum iter is the maximum number of iterations. Specifies the maximum number of iteration that the algorithm will run to optimize the model during training. In simple terms, it controls how many times the algorithm will go through the training data to update and refine the model. Understood. In machine learning, the algorithm adjusts the internal parameters like weights to improve its performance. This process happens iteratively. With passive aggressive classifier, it updates the model in each iteration. We saw earlier, right, that passive aggressive classifier model, what it does, if it fails to correctly predict, it updates the data, right? It trains itself. So how many times we have to do, how many iterations we have to perform on the data set. So that is why this maximum iteration parameter is used for. So it updates the model in each iteration based on the error it encounters, right? So that is why. Now sets the upper limit how many times the iteration algorithm is going to make. Yes, each iteration allows the model to learn from mistakes it made from the previous iteration. The passive aggressive classifier gets updated aggressively when it misclassifies an example, adjusting its decision boundary to fix the mistake. Right? So, understood. Let's copy and paste it here, not here. Yes, correct. Right. So, we have created the model. Let's train it. So, we'll train it on the train data against the target. Now, the step number 7 is make prediction and evaluate. So make prediction and evaluate. So prediction is going to be on the model dot predict x validate. Let's print the predictions. It is taking time. Yes, let's wait. And we have an error. Let's remove it. Let's run it again. Let's get the accuracy on. Let's run it again. Oh, sorry. I'm training it on. No, I'm training. Oh, I'm so sorry. Here I should have used the numerical converted data frame that we had created x from the TfidfVectorizer, vectorizer, and I was giving x the original data frame. So now it should run correctly. It is running correctly. So let's print it and see. Oh, we see some predictions it has made. So now let's see the accuracy. So the accuracy is going to be of the actual value, which is the and the predictions. Print the accuracy score, and it's going to be accuracy score. Let's follow and complete the whole evaluation step. Let's see the confusion matrix also. Why I'm doing it right now altogether is because it is taking time to run this whole program, right? Script. So what we do, we'll write both confusion and classification report so that we can analyze all together. So confusion matrix again against the actual value and the predicted values. Printed confusion matrix, and it is going to be confusion matrix, and then the classification row report is going to be classification of the actual values and the predicted values. And then the printed classification report is classification report. And now let's run it. It is taking time. Yes, we can see the accuracy is coming really good. It is coming 99%. Uh, Very less number of false positive and false negatives. True positives and true negatives are like really good number, 4620 and 4304. This is we can see from the confusion matrix. Then the precision also is very good. The recall so the model is performing really great. I'm just trying to see if I decrease the number of iteration, uh, what it the will I see any change in the accuracy. So earlier the maximum iteration for the passive aggressive was 50. Now I've dropped it to 30. The okay, it did actually it improved. Strange, but it the accuracy got improved from. You can see the numbers here. It is coming less, and that's what we want. It should come less, right? Now, if I make even less iteration. Oh, even then less, right? But somewhat it got increased, right? So I'm going to go ahead with the 50 iterations, right, for starters, because I guess the data is less for us. So I'll go with the 10 iterations, and then now we saw that this is how it is going performing for the 10 iterations, right? Really good, 99.4%. Now what I'll do, let's visualize it. Step number 8 is going to be visualization. So it is going to be, we will use PLT matplot library to create a figure, and the size of the figure is going to be 10 7 is to 5. Then we will use Seaborn, that we are referring with SNS, to create a heat map. The data is going to be confusion matrix, and then we will do what? Annotations are going to be, yes, we want annotations. The format is going to be D decimal. Then the extricable values are going to be 0 or uh, let's go back. Is it going with numbers or is it going with real or fake? Let's go with nothing. Zero ones. I last problem also we saw that for zero ones we did not print the number, the labels for the cells. So the color of the is going to be blues. Let's put it in the as strings. Now just define the x label is going to be predicted values, is going to be actual values, and the title is going to be confusion matrix, and just show it, and then let's run it. So this is how it is looking. Let me take a screenshot of it that I can use for creating the progress post on my tech journal. This is what I'm talking about. Each day I create a progress post and a video that I'm recording right now. So yes, it seems to be working. Now let's commit the code. Day 8, and now I want to see what the difference is. So I restore day 7 and day 5 actually. Now let's see if the status is clean. Yes, so we only see day 8. Let's commit it. I want to first mention here, download the data set from Kaggle, uh, and put in dataset directory. Okay, correct. I might, sorry, directory datasets. uh, Let me add it again. Day 8. Now commit it. Add code for day 8 problem and push it, and see if I can see the changes here. Yes, I can see the changes here. Just now I made it. Yes, it looks good. So now I'll go and write progress post about it, or maybe in the evening I'll do that. So yes, today I'll do it after this stopping this video. So I should stop it now. Thank you very much. We'll hopefully meet again tomorrow. So let me go to the screen recorder and